Question number 13 says if a plus bx upon a minus bx is equal to b plus cx upon b minus cx is equal to c plus dx upon c minus dx, where x is not equal to 0, then show that a, b, c, d are in GP. Now, for showing a, b, c, d are in GP, what can we prove? A, B, C, D are in GP, that implies common ratio B upon A should be equal to C upon B is equal to C upon D, D upon C. See, this implies A, B, C, D are in GP. Since each of these is equal to the common ratio, right? So, ratio of two consecutive terms, ratio of two successive terms will be same, right? That's what we are to prove. Okay. So that's our target somehow. Can we find B upon A somehow from here? Yes or no? By the way, we could also go ahead and show this, or A upon B is equal to B upon C is equal to C upon D. Mind you, this is also okay, right? That's not an issue, okay? Because you just have inverted ratios, that's it. Here also you can take, okay, common ratio in this case will be R, in this case common ratio will be 1 upon R for that matter. Common ratio will be R and this ratio will be 1 upon R. This will be equal to 1 upon R. Okay. What else? So, let's focus on this complete expression. A plus bx upon A minus bx, B plus cx upon B minus cx, C plus dx upon C minus dx, and the important thing that I observe over here is that I see C plus D, C minus D type of thing, yes. A plus B, A minus B type of thing, yes. Can you think of applying component dividend, or do you see that this has been obtained by applying component dividend on something? So how will we get that original thing? We'll apply component dividend on this thing. What does component dividend say? This is an idea, a concept borrowed from the topic ratio and proportion. So if A upon B is equal to C upon D, this implies that A plus B upon A minus B will be C plus D upon C minus D. Similar step in left hand side and right hand side will make the two ratios still equal, right? And this particular step going from here to here is called componendo and dividendo. This is what we need, right? A plus B upon A minus B is equal to C plus D upon C minus D. Is that okay? Yes. So can we apply that? Okay, there are three ratios given over here. Doesn't make a difference. This, and this. We'll apply component dividend on all. So A upon B is equal to C upon D is equal to E upon F. Had there been E upon F, E plus F upon E minus F would have come over here. Doesn't make a difference, right? So we'll apply component dividendo and on this. What do we get? Sum in the numerator A plus bx plus A minus bx. In the denominator you will get A plus bx minus A plus bx. Do you see this? Yes. This is B plus cx plus B minus cx. Numerator minus denominator. Minus B and plus cx is what you will get. Which is equal to sum of numerator and denominator C plus dx plus C minus dx upon C plus dx minus C and minus or minus dx. This is what you get. And now, after applying this step on this, do you see that certain terms will get cancelled? In the numerator, in the denominator, in the numerator, in the denominator, in the numerator, in the denominator. And what are we left with? 2a upon 2bx, 2c upon 2b upon 2cx, 2c upon 2dx. I cancel 2 and 2, 2 and 2, 2 and 2 from the numerator and denominator. And if all of these ratios are equal to lambda, then can you say that a upon b is equal to b upon c is equal to c upon d is equal to lambda x? Can you say that? Or more importantly, if these three ratios are equal, this implies that if these three are equal, then this implies that A, B, C, D will be in GP. Will be in GP. That's what you can observe. And that's the complete proof of this question number 13th, as you can see over here. Is that all? Yes. What will be the common ratio of this GP? That's the important thing to note. So common ratio is actually B upon A. That will be the reciprocal of this. That is 1 upon lambda x. Okay, that's all. Other than that, nothing else. This is question number 13th.